So what we're going to be talking about today is just the end of our unit, and we're going to talk about humans and how they affect, how they impact the environment. And we started talking about, that human population growth is a major factor. There are just so many people on the earth, 6 billion or so, that they consume huge amounts of resources. They need food, they need water, they need necessities. They also use up a lot of resources for things that are not necessary for survival, things like cars and phones and things like that. And all those things use resources. All those people take up space. All the food they needs to grow somewhere. So population growth is an important factor. We're going to talk about some specific issues today, some specific environmental problems. And one of those is this issue of invasive species. Invasive species are species which humans, either on purpose or inadvertently, bring from one area of the earth to another. So when you take a species that's not native to your area and bring it into your area. Now often they become a pest. They become damaging to the environment. Because, for example, a fish is taken from Southeast Asia, brought to North America, and released into streams here. Well, it probably has no natural predators. Okay? And often, because they have no natural predators, their population can grow and they start to displace native species. They may start to outcompete the native fish that have been living in the ecosystems of North America for a long, long time. Okay? And often they grow, their population grows uncontrollably. They can disrupt the food chain, disrupt the ecosystem. And some examples, there's a lot of examples of this. Many pest species are not native to our area. Rats are not native. They actually came over probably on ships from Europe when trade between Europe and North America became common. This is a plant called kudzu. It's not around here, but you can see it down south, and this super fast-growing plant that was introduced into North America. This is, again, in the winter, dies back. This is a little cabin. It's a little hard to see in this image, and some trees. You can see in the spring, summer, early fall, just completely, it covers this complete house, and it works its way up the trees. In the south, when it's growing, it covers telephone poles and wires. If there's like a car that hasn't been moved in several months, the kudzu will cover the entire car. It's a super invasive plant. Okay? And again, it's fast growing. It outcompetes any other native species. And so obviously, what's growing here are not the native plants that typically would have grown there. Rabbits were introduced into Australia in 1859. Just 24 rabbits were brought to Australia. There were no rabbits previous to that. Today there are billions of rabbits in Australia, and extreme pests. Again, they grow out of control. They eat all the vegetation. This is a snakehead fish, or lampreys. One that's common. I'll show you in a minute. And so they're hard to control because they're often fast-growing and good competitors. They're often very, very hard to get rid of. Some other terms here that you should recognize. I usually call them invasive species. Other terms that are sometimes used: exotic species, imported species, foreign species, non-native species. They all really are referring to the same thing. Species brought from one area into another, which often causes problems. And they are difficult to control. You can try to physically remove them. You could physically try to individually, destroy the species. One technique is to introduce predators. Because they often don't have predators, you could introduce a predator for that species that might help control it. But again, sometimes if it's a non-native predator, that becomes an issue. Some examples, and these are mostly things that you would see around here. Zebra mussels. If you ever go swimming in lakes around here, you may have seen zebra mussels. They're a mussel, it's a bivalve, like a clam. And zebra mussels were introduced to North America on the ballast of ships, in the water that ships take in the transport of cargo from Asia to North America. And they have grown out of control. These mussels outcompete native mussels. They attach to lots of surfaces. They clog up water intakes and drains and so forth. They've spread from the northeast, and they've been making their way west. People cut their feet on them, you step on them. They're a serious pest in our area, in the Great Lakes and the Finger Lakes and so on. This is another invasive plant around here, purple loosestrife. Purple loosestrife was an ornamental plant. It was brought for like landscaping because it has these purple flowers. Well, it's grown out of control, and it actually lives in marshy areas, wetlands, and it has displaced native cattails, which is what the native vegetation should be. If you know where the Utica Marsh is, if you're driving through North Utica over to like near Walmart, BJ's, and Bass Pro, so you go over that highway, on the left is the Utica Marsh. If you look there around now, starting into the early summer, you'll see just tons of purple flowers in there. That's all purple loosestrife. It's all non-native plant. Problem is, it's not a good food source for native animals. Okay? Cattails are, but this purple loosestrife is disrupting them. I used to do a project when I taught living environment like 5 or 6 years ago. We would raise in our class beetles, European beetles that prey on loosestrife, and we would bring them to the marsh and release them to help control the purple loosestrife that's growing there. Gypsy moths. Gypsy moths were introduced to North America. They were brought for silk production, but then escaped and became established. And they defoliate trees extremely. They eat away at the leaves and damage them. Dutch elm disease is an important one. Dutch elm disease is caused by a fungus that's spread by a beetle. It came from Asia. Elm trees used to be one of the most dominant trees in North America. They have been severely damaged due to Dutch elm disease, and the number of elm trees is decreased drastically by this disease. Phragmites is a common reed you see all the time around here. It's got the little fronds at the top. Again, lives in wet areas, displaces. These would be the native cattails that should be there. Starlings, little blackbirds we see all over. They were brought to North America because someone wanted to have all of the birds mentioned in Shakespeare's plays. So I think they brought a dozen starlings and released them in Central Park in New York City. They since have established themselves throughout the United States, outcompeting native species. Pigeons, rats, all of these are imported non-native species. Water pollution is a major environmental problem. Water pollution is caused by obviously adding chemicals to the water. Sometimes it's raw sewage, human waste that's not treated. Sometimes it's metals, toxins that are used in manufacturing can be added to water. Sometimes it's even heat added to the water. That's called thermal pollution. This graphic shows the water being released from a nuclear power plant, and the colors represent the temperature of the water. Nuclear power uses water as a coolant, and so the water goes into the plant. It's used to cool down the equipment, and then it's released. It's not polluted in terms of chemicals or any nuclear material, but it's a higher temperature, and that disrupts the ecosystem. It carries less oxygen. Certain organisms can't tolerate that temperature. So there are various ways that water can be polluted. When sewage goes into the water, it adds nutrients to the water. Okay? Sewage, as it breaks down, releases nutrients. That leads to a process called eutrophication, which is when algae and producers grow out of control because we're adding fertilizers to the water. Toxic materials, DDT, PCBs, heavy metals. These are toxic substances. They make their way through the food web. They bioaccumulate as one organism eats another. They get in higher and higher concentrations and end up damaging those organisms. So how do we solve some of these problems? Well, we have find proper ways of disposing of waste. We can treat wastewater before it's actually released. You know, all the water that goes down your sinks and toilets and showers and so forth, it ends up going back into the river around here, the Mohawk River. But it gets treated beforehand. Goes to the sewage treatment plant, gets treated so that it's safe. If that water were not to be treated, it can lead to some major problems. You know, so the less use of pesticides and fertilizers, you know, if you treat your lawn, if you live near a stream, you treat your lawn with, you know, pesticides to kill the dandelions and things like that. Well, a lot of that ends up in the water. As it rains, the runoff carries many of those chemicals with it. Those chemicals contribute to some of these issues. Now, there's lots of areas where there used to be factories that severely polluted. Onondaga Lake in Syracuse is one of them. It's been remediated or cleaned up somewhat. In Utica, the harbor area used to have a bunch of industry there, Niagara Mohawk, and they polluted the water there. It's being cleaned up and it's about to be redeveloped as well. So these pesticides we often use to control pests, you know, like, you know, you spray something on your lawn, it kills the dandelions, so your lawn looks nice and green. Or you might spray an insecticide on your tomato plants so that aphids don't eat the leaves of them. Well, these things can be damaging. There are alternatives that we call biocontrol. Biocontrol is what it sounds like, using living organisms to control another species. And there's lots of different ways we have of doing this. So you've never seen these?
Yeah.
What are these meant to capture?
Beetles.
Yeah, Japanese beetles. You ever seen Japanese beetles? They have like a rainbow sort of sheen to them. They eat the leaves of plants, they defoliate things. There's lots of them. They often go in high concentrations. These are Japanese beetle traps. They're treated with pheromones, chemicals that insects use to sort of communicate with each other. Chemicals that attract insects to find mates. And so by putting these pheromones on the trap, that attracts these Japanese beetles, and they get stuck in the bottom here. This whole thing fills up with all these beetles, kind of gross. So that's one way, using pheromones to trap. Often sterile males are introduced into the population. This has been tried with mosquitoes. In fact, they're trying it again. That many types of mosquitoes will mate, the females will mate just once. And so by releasing many males that have been sterilized and are not capable of reproducing, those sterile males still mate with the females, but they can't fertilize the eggs, and therefore no young are produced. So that's one way of trying to control some insect populations, sterilization of males. Sometimes we introduce a natural enemy, a natural predator, a natural disease of an organism into the ecosystem. Okay? There's a type of virus that kills rabbits in Brazil, myxoma virus. They cause them to develop these skin wounds that eventually kills them. So rather than using chemicals or hunting, you can use disease or predators.
Why are they killing rabbits?
Because again, they were introduced there, and they're a non-native invasive species that are sort of destroying the ecosystem. Same thing in Australia. Coleoptera beetles, this is what we used to do in class. We used to raise these little beetles, and they eat loosestrife and only purple loosestrife. So we'd bring them to the marsh, release them, and hope that they would help control the population of loosestrife at the marsh. Now you have to be careful, because if these beetles that we're releasing, it's another non-native species, if they ended up eating the cattails, well, we would just be making the problem worse. So they have to be carefully researched and understood. Fire ants, okay, which have been making their way up from Central America to North America. They can be controlled by special phorid flies, which attack these ants and decapitate them, killing them. So there's lots of ways we have of controlling some of those species, other than using pesticides. acid precipitation is a type of air pollution. Acid rain, I'm sure you've heard of. And it's caused by the release of certain gases by burning of fossil fuels. Sulfur and nitrogen are the main culprits. For example, if you drive your car, or your parents drive their car, I should say, unless they have an electric vehicle, they're burning gasoline, then part of the exhaust is sulfur and nitrogen. And when those are released into the air, they react with water, and they form sulfuric acid, nitric acid. And that reduces the pH of the rain, mixes with water, and so the rain, the snow, the sleet that falls has a lower pH. It's acidic. And that affects the ecosystem. As this rain falls in lakes and streams, it causes the pH of the stream or the lake to drop. Some fish and insects and so forth can't tolerate those conditions, and so they end up dying off. Certain soils don't have a natural buffering capacity. Many soils, as they absorb acid precipitation, they can neutralize that acid. But some types of soils are unable to do that. This is a major problem in the Adirondacks of New York. They're vulnerable. The spruce trees and so forth are vulnerable to these acid conditions, and you end up with large areas of forest that have been destroyed. Here you see a statue. This is a gargoyle statue, probably made out of limestone, which reacts significantly with acid rain. And you can see this one was preserved. It was inside. This one was not. All the features have been worn away from this because of that acid rain. So solution, well, we can reduce the amount of fossil fuels that we're burning. Burn cleaner fuels. Could scrub the exhaust from these factories to clean it before it's released. You know, this graph shows here sort of which species, an example, can tolerate various conditions. You know, at a somewhat neutral pH, all of these organisms can survive. But as the pH of the lake or stream starts going down, as it's becoming more acidic, well, first you lose the mussels, around 5.5. Then you lose the smallmouth bass and the mayflies. And as conditions get more and more acidic, you have more and more organisms that cannot survive. There are some lakes that are dead lakes, they're called. They have become so acidic that basically nothing can survive in them. They look very clean and clear because there's nothing living in them, but they're actually polluted and their pH is too low, and that's why there's nothing living in them. This is a major problem in the northeast of the United States, and part of the reason is because in the United States prevailing winds are west to east. So pollution from factories in the Midwest blows into the eastern areas of the United States, and that pollution causes rain in our area to be acidic. Ozone depletion. The ozone layer is a layer of O3, ozone we call it, very, very high up in the stratosphere, way up in the atmosphere. And it blocks ultraviolet radiation from the sun. Sun releases not just visible light, but ultraviolet radiation, which causes us to get a tan and a sunburn, and also increased risk of skin cancer. The ozone layer filters out a significant portion of that ultraviolet radiation. The problem here is that we produce certain chemicals that damage and destroy the ozone layer. The main chemical that does this is called chlorofluorocarbons, CFCs. And they were once used much more often than they are today, but they are used as propellants in aerosol cans, spray cans. They're used in refrigeration systems, air conditioners, refrigerators, freezers, things like that, and other products. And these chemicals made their way into the atmosphere, and they react with the ozone layer and eat away at it. Okay? And so the thinner the ozone layer, the more ultraviolet radiation that reaches the earth, and that could lead to more skin cancer, cancers of the eye, damage to plankton in the oceans, and so forth. series of problems. There's actually a hole in the ozone layer around the South Pole. It gets larger and smaller depending on the season and so forth. You can see over a period of time, this is what's happened to the size of the hole in the ozone layer. It's increased. Okay? But what's happened recently? Yeah, it's leveled off. It's because of an agreement called the Montreal Protocol, where countries from around the world agreed to limit their production of CFCs and come up with alternatives. So we've reduced the use of CFCs in many cases, and therefore this problem has sort of leveled off somewhat and it's improved. So things can be done. And then probably the last major issue we'll talk about, but it is an important one. Global warming, climate change, we might call it. What causes climate change? What gas? Greenhouse gases, and there's several of them. The major one, what gas do humans release in the atmosphere more than any other? Carbon dioxide. It's caused by carbon dioxide being released in the air. Basically, anytime, I guess I said that, anytime we burn anything, it releases carbon dioxide in the air. And the main thing that we burn are fossil fuels. Burning coal, oil, natural gas, they release carbon dioxide into the atmosphere. And carbon dioxide in the atmosphere acts kind of like a blanket. As we add carbon dioxide to the atmosphere, it sort of thickens the blanket. And this blanket basically captures heat and doesn't allow it to escape from the earth. Normally, as the sun's rays shine into the earth, they heat up the earth, and then the earth radiates excess heat and it goes back into space. The more carbon dioxide that builds up, it traps that heat closer to the earth and causes the temperature to rise. If you see a couple graphs here, we see, this is just since the year 1000, we see the amount of carbon dioxide in the atmosphere, and we see what's happened in recent times around the Industrial Revolution. And yes, carbon dioxide cycles over long periods of time. This is a long period of time, 400,000 years ago. Goes through cycles. And this is one of the reasons we've had ice ages in the past, is because of natural fluctuations in carbon dioxide. But if you follow the cycle and you look where we are today, well, what has happened to that cycle? It's short-circuited. So the highest CO2 levels in the past 400,000 years were about here. Well, today they're up here. And this trapping of heat is called the greenhouse effect. Okay? As solar radiation comes into the earth, okay, the earth absorbs it and then radiates some out. The greenhouse effect traps that heat in the earth's atmosphere, causing the temperature to increase. It's like putting an extra blanket on the earth. The predictions as to how much temperature will increase, well, predictions vary drastically. There's lots of different computer models that scientists do to try to predict this. Okay? Predictions can be from 1.1 to 6.4 degrees Celsius, okay, over the next 100 years or so. We see a graph of temperature since mid-1800s. And again, if you follow the 5-year average, it's probably a better indicator than annual changes. But you can see it's gone up and down, but we're on a certainly on an upward trajectory. And our temperature continues to increase. The amount of warming depends on how much carbon dioxide we add to the atmosphere. Depends. If there are no changes, these are the predictions. So these are various models used to predict temperature. And these predictions by 2100 from, at a low end, 2 degrees Celsius, up to 5 degrees Celsius by these models. And again, that has major impacts on the Earth. Because as the Earth gets warmer, ice melts, glaciers melt, ice sheets melt, and that water ends up in the ocean, and sea level rises. And a rise in sea level leads to flooding of coastal areas, obviously. Increased ocean temperatures leads to more intense storms and hurricanes and so forth. Warmer water holds less oxygen, so there's less oxygen for the organisms that live in the ocean. And as the temperature warms up, certain species may be forced out of an area. Some species may come into an area. We have mosquitoes that are able to work their way into areas they've never been able to survive before. Often disease-carrying mosquitoes can expand their range as the earth gets warmer. Migration patterns change. Increased forest fires. The glaciers are about half of what they were in 1800, okay? And that leads to many problems in ecosystems. It also leads to many problems with humans. These are some effects of global warming on humans. Changes to the growing season, more droughts, barriers to floods. The more global warming happens, the more flooding there will be. People will need to find other places to live if their homelands become inhospitable. More droughts, less water stored in the snowpack to provide drinking water. Increased pollen, allergies, asthma, more heat waves, and so forth. So there are a lot of negative effects of all of these with global warming. There are solutions though, things that we can do. Controlling population, conserving resources, pollution controls, ways to preserve species, and so forth. So check out the website for your topics for ecology quiz tomorrow. And we'll do some review after we're done with that.